Welcome to my lecture. This is on the central limit theorem with probability. So here's going to be the example, but first I want to state the central limit theorem. So let observations x1 through x sub n be independent and identically distributed. With mean mu sub x and variance sigma squared of x. Then the average x bar is normal with mean mu sub x and variance sigma squared of x over n. Okay, so keep the central limit theorem in mind. Okay, and let's consider this example. Males aged 18 to 25 have an average height of 67 inches and a standard deviation of 4 inches. Assume the heights are normally distributed. And we have two tasks. So, one, calculate the probability a randomly chosen male has a height of 68 inches or less. And two, in a random sample of 30 males aged 18 to 25, calculate the probability the average height is less than 68 inches. Okay, so let's proceed to answer the very first question. Let x be the height of a single, randomly chosen male aged 18 to 25. We want to calculate probability x is less than or equal to 68 inches. Well, to do this, we just take the z-score, so calculate probability z is less than or equal to 68 minus the mean of 67 divided by the standard deviation of 4, And from here, you'll use the table, or you'll use R. And you'll calculate that this probability is 59%. And that's the probability a single male is less than 68 inches. For 2, you're asked to calculate the probability the average height, that's represented by x bar, is less than or equal to 68. Now, one thing about x bar is it's normal with mean equal to 67, but its variance is going to be equal to the old variance, which is 4 divided by 30. Excuse me, the old variance is going to be 16 because it's the square of the standard deviation. Okay. So remember, the standard deviation was 4. That's sigma. So variance is equal to sigma squared, which is 4 squared. So I needed to do that as a 4 squared right here. Okay, and this is the part that's the most important. So if I want to calculate this probability, I just take the z-score, because that's what we do for normal distributions. We standardize it. We calculate the probability 68 minus the mean of 67, but now I have to divide by the standard deviation, which is 4 over root 30. That's the square root of the variance. And now we'll again use a table, or you can use R, and you'll calculate that this probability is about 91.4%. That's quite different than the 59%. This is for the average. This is for an individual. So that's an example of probabilities with the central limit theorem. I want to emphasize here that it's a lot harder for a group of individuals, a group of observations, to be away from the average than it is for a single observations. That's a big reason why these probabilities are different. Okay, well, thanks for watching.